Welcome to the Carbon to Value Initiative Year 1 Cohort Showcase. Thank you so much for joining us today. My name is Frederick Clerk, and I'm the director of the Carbon to Value Initiative, a multi-year, multi-stakeholder program creating a thriving innovation ecosystem for the commercialization of carbon tech. It's a pleasure to be with you today, even virtually, and we hope we'll have more luck in 2022. In the meantime, we have a great program for you today. We'll start with some background on the C2V Initiative and some outcomes that we've already seen. Then we'll jump right into the startup presentation. Not only will you learn about their unique solutions, but also what they have accomplished over the course of the program and what they need going forward. Halfway through, we'll have the pleasure to hear from our keynote speaker, Dr. Emily Grobert, from the Office of Carbon Management at the US Department of Energy. And at the end, we've organized some time for you to network with one another. So stick around for that part. Finally, we have some quiz questions for you to test your carbon tech knowledge. You can find them in the polls tab on the right top hand corner of your screen. We'll announce the correct answers at the end of the speaking program, so stay tuned. With that, I'd like to hand it over to our executive leadership, Pat Sabinsley and Emily Reichert. Pat, Emily, welcome. Thanks for joining, and over to you.
Well, thank you, Fred. I'm Emily Reichert, and for those who may not be familiar to my organization, Greentown Labs, we are the largest climate tech incubator in North America. Our mission is to provide climate tech entrepreneurs with the community, resources, connections, and laboratory space their companies need in order to thrive. And we currently support about 180 companies at our locations just outside of Boston, in Somerville, Massachusetts, and in Houston, Texas.
Terrific. And I'm Pat Sapinsley, the Managing Director of the Urban Future Lab at NYU Tandon School of Engineering. The Urban Future Lab is the center of climate tech innovation in New York State. We help entrepreneurs who have market-ready solutions to climate change to achieve scale. Our Acre Incubator, our accelerators, and our community events all seek to create an equitable clean tech ecosystem.
So you may ask, what is carbon tech? For those of you who may be new to the initiative this evening, the term carbon tech refers to an emerging sector where value is created from the conversion of industrial and atmospheric carbon to fuels, fertilizers, chemicals, plastics, materials, and other commercial products. Because as we saw in the recent IPCC report, reducing greenhouse gas emissions alone will not be enough to keep global warming below an average of 2 degrees Celsius. More than 100 gigatons of carbon in the form of carbon dioxide must be removed from the atmosphere by 2050. But the good news is, analysts predict that carbon tech could comprise a $1 trillion market opportunity in the US alone, in sectors as diverse as building materials, fuels, chemicals, agriculture, and consumer goods. But today, carbon tech is still nascent. Many promising solutions will not be cost-effectively scaled in the timeframe necessary without support for their expedited development.
So achieving scale and jumpstarting a new industry is exactly why we launched the Carbon to Value Initiative in 2020, following the 2019 State of the State speech from New York's Governor Cuomo, where he pledged to spend $15 million on several carbon tech programs, highlighting that this type of technology would be critical to achieving New York State's ambitious climate targets. New York has now mandated a goal of 0 emissions from the electricity sector by 2040 and 100% economy-wide net zero emissions by 2050. We're therefore proud to say that New York is leading the nation with its work on carbon removal, and that the C2V Initiative is leading the nation in building a new carbon tech industry. The C2V Initiative is a partnership between Greentown Labs, Urban Future Lab, and Fraunhofer USA, and reflects our shared commitments to a decarbonized future. Each partner brings its own strengths, networks, offerings, track records, and unique areas of expertise.
And to illustrate Pat's last point, a key ingredient of the C2V initiative is Corporate Partnership Startup Accelerator. And for this, we built upon the Greentown launch model. Greentown launch programs give startups a unique window into corporations' inner workings, which invariably helps startups understand how to pursue successful partnerships that are necessary to scale their companies. After 6 years and 12 launch programs with leading corporations on major climate tech sector focus areas, ranging from offshore wind to energy storage, we've gotten pretty good at it, and we're happy to share this expertise with the C2V initiative. Now, what did we achieve this year with C2V? Well, when we first put out the call for applications in December 2020, we were honestly not sure what to expect, but entrepreneurial interest in carbontech actually absolutely exceeded our wildest expectations. We received 131 applications from 26 different countries across 5 continents, showing that a program like C2V that focuses on ecosystem building and partnerships was needed to support these carbontech entrepreneurs. With so much demand, always a good problem to have, we selected 10 amazing companies into the first cohort, an acceptance rate of less than 10%. And fun fact, we were aiming for 8 startups in the first cohort, but they were all so good, we ended up going with 10.
They were amazing. So this year's cohort features that amazing diversity of companies. They range from carbon capture to carbon upcycling to carbon removal. They produce chemicals, fuels, and materials. One of the interesting things that came out of this year's program is the synergies from within the cohort itself. There has been a lot of camaraderie between the startups who might never have met otherwise and have now spent lots of time together in our workshops. Some of them are even exploring the possible formation of a policy advocacy group specifically focusing on carbon utilization. In addition, there are several potential partnerships brewing between complementary solutions, for instance, between the carbon capture companies and the carbon utilization companies. These partnership opportunities exemplify the connective tissue that is needed to build a real carbon tech industry.
And some other important outcomes worth highlighting are around C2V's core mission, which again is to catalyze the carbon tech ecosystem and create partnership connections. C2V has built from the ground up an ecosystem composed of more than 120 people that are now working together on carbon tech and not in silos anymore. They include startups, mentors, government representatives, corporate teams, and nonprofit stakeholders. In terms of partnerships, we've tracked over 70 new connections made between startups and members of our Carbon Tech Leadership Council, a group of corporate, government, and nonprofit leaders who can work closely with startups to accelerate their scale-up and commercialization. And frankly, that number is probably conservative since it's hard to track down what startups are up to on any given day. You'll hear a bit more about these connections directly from the startups in just a bit. One of the examples that we're particularly proud of, though, was when one cohort startup, Carbon Free, announced a partnership with CLC member Fluor to scale up and deploy their next generation CO2 mineralization technology. And that's just the beginning, because we know things like this take time and we'll witness many additional outcomes from this work and these relationships stretching far into the future.
Right. So speaking of the future, we are very excited to continue this work into the next 2 years and to include new participants. So first, if you're a corporate, we anticipate welcoming a select number of new Carbon Tech Leadership Council members. You'll have your finger on the pulse of a new $6 trillion industry worldwide, and you'll get to engage with other carbon tech leaders who will access innovation in this field. Second, if you're a startup, a new call for applications will launch later this year, and we look forward to convening another amazing cohort for year 2. So if you're interested in engaging with us, please let us know via our website, which is posted in the chat. After an amazing first year, I personally can't wait to see what's coming in year 2. But let's not forget our great partners who made this all possible. A big thanks goes to NYSERDA, New York State Energy Research Development Authority. New York State has an incredible vision to be a global leader in carbon tech. Thank you, NYSERDA, for supporting the C2V Initiative. And thanks too to the Canadian Consulate of New York. These two governments, Canada and New York State, have been extremely supportive of this new carbon tech industry. And thank you, of course, to the entrepreneurs themselves. I remember when I attended the down selection interviews, I got very inspired by these startups. These are the people who can actually engineer our way out of the climate crisis that we created. So a huge thank you to the entrepreneurs, the innovators, the company builders, for your imagination and for your belief that we can beat this problem.
And next, we'd like to thank our carbontech Leadership Council members who represent a broad range of industry verticals, all of which have the potential to adopt and advance carbontech innovations. The diverse and complementary views of these leaders that we've heard in these meetings are just critical to building a robust carbontech ecosystem. So a big thank you to our carbontech Leadership Council members and their teams for the time they dedicated to this program and for their support overall. Of course, we also want to thank our amazing NYSERDA entrepreneurs in residence and our Greentown launch members. C2V startups need support and mentorship to build a successful business from the ground up. So thank you for the time and the expertise you've contributed over the course of the program.
And of course, where would we be without our stellar team from Greentown Labs, Fraunhofer USA, and the Urban Future Lab, led by the outstanding Fred Clark. So thank you to all of you. Setting up and running such a complex initiative takes a lot of work, coordination, and collaboration, and you have delivered beautifully. We look forward to continue to work together over the next 2 years.
Seriously, what an amazing team. And with that, we'll hand it back to you, Fred.
I think I was muted, so I'm going to start that over again. Okay, so I was thanking Pat and Emily for their kind words and saying that it's been a lot of work, but it's also been a lot of fun. And I look forward to the next 2 years. And so without further ado, we're going to jump right into the startup presentations. We'll start with Alison Dring, who's the CEO and co-founder of Made of Air out of Berlin, Germany. Alison, over to you.
Hi, thank you, Fred. And thank you to Urban Future Lab, thank you to Greentown Labs, and to Fraunhofer USA and partners for the wonderful program. I'm Alison Dring, I'm the CEO and co-founder of Made of Air. Can I have the next slide, please? Made of Air is a carbon negative materials company, and our purpose is pretty straightforward. We're in business to reverse climate change. Next slide, please. So our product is a carbon negative thermoplastic compound that manufacturers can use as an alternative to fossil plastics and other high emitting materials. The material is not only a way for manufacturers to pivot away from systemic reliance on fossil materials, but it also generates net negative emissions, effectively turning manufactured goods into permanent carbon sinks. This material has a net negative footprint of -2 tons of CO2 per ton of material. Our work builds on and amplifies the work of nature. Our feedstock material is a wood waste, and as a plant material, this waste stream has absorbed CO2 in its lifetime via photosynthesis. However, typically as plant materials decay, what you have is the CO2 being re-emitted back into the atmosphere. And our process interrupts this natural cycle, and we prevent the re-emission of CO2 back into the atmosphere from the decay of the biomass. And how we do that is by collecting the waste biomass and converting it into biochar. And in that step, we're taking the CO2 in the plant cells and converting it into a pretty much an elemental carbon. And in this step, sorry, go back one. In this step, we don't see the CO2 returning to the atmosphere. We then process the chars to enable them to be compounded into a thermoplastic. And in the making of this material, we're permanently sequestering the carbon stored in trees to create durable, high-performance materials. Okay, next slide. So our compounds are focused on durable products with lifetimes of 10 to 30 years. In consumer goods, in furniture, and in the automotive sectors, we act as a plastics replacement. In the built environment, where you have a high contribution of global emissions, somewhere around 40%, the material can act as an alternative to mined materials or other high-emitting materials like aluminum paneling or high-pressure laminates or cement fiberboards. Next slide. We're partnered with global brands such as H&M, Audi, and BMW to deliver the material as a carbon removal strategy that focuses on one of their pain points, which is Scope 3 emissions. This year, we delivered the material as a facade panel for Audi for one of their dealerships outside Munich. And this picture you see in the middle here is actually the world's first carbon negative facade. Next slide. So I'm really happy today to be here to present some of our impressions on this fantastic program and some of our learnings from the C2V Initiative. Next slide. So what was important to us from the beginning of C2V was to establish working relationships with companies and organizations that are pioneering in this space. As was previously mentioned, this is a very young, emerging space, and we felt it was important to connect commercially and to create alliances within this community. So at Gore, we were introduced to an innovative ingredient brand that's very much an example of what Native Air is striving to be. We also met with several carbon platforms to learn best practice around accounting, things like policy, crafting messaging. And finally, with Fluor, we engaged strategies that are going to help us scale up our production. Next slide. So some key takeaways from us. We learned that as a company, or not only as a company, but as a community, we're all a bit ahead of the curve. And that means that there are a lot of opportunities out there, but it's also a lack of precedent that can lead to many missteps. We've also seen that in the market, there's a lot of misinformation to overcome. And finally, we found a lot of supportive partners and the beginning of a joined up effort around C2V and CDR. Next slide. In the last year, we've had a lot of momentum at Native Air. We raised our seed round. We closed that in June of this year. We closed at 5 million euros. And next year, we'll be opening our first pilot production line, and that'll be here in Germany. And we're currently crafting a powerful message around negative emissions with our partners. Next slide. Finally, I just want to leave you with a thought that's very dear to us. Changing our base materials implies a systemic shift in resources. And we see this as nothing less than a change in paradigmatic thinking. Materials have the ability to make or break our climate targets. And at Native Air, we firmly believe that the future of materials is in carbon storage. Thank you very much.
Thank you, Alison. I just can't wait to see more carbon sequestered via biochar into materials all around me. Thank you for the work you're doing. Up next, we have Doug Staker. Doug is the VP of Business Development at CarbonQuest out of New York, USA. Doug, over to you.
Thanks, Fred. Good afternoon. I'm Doug Staker, Vice President of Business Development at CarbonQuest. At CarbonQuest, we help large building owners decarbonize their operations. Next slide, please. Our core team is a group of seasoned entrepreneurs that have worked together to build multiple companies over the past 30 years. We have focused on building companies that solve hard problems in the telecom and energy markets. For the past 12 years, we've been focused on the built environment with an emphasis in New York City. Next slide, please. In urban environments, buildings are responsible for producing up to 60 to 70% of the local CO2 emissions. New York City has implemented a plan to tax excess carbon emissions from buildings at $268 a ton starting in 2024. There's a lot of discussions around electrification of cities to improve the environment. The challenge with electrifying many of these buildings requires time and build out of an expanded capacity of the grid and the generation that supplies it. Many corporate groups have goals within their ESG directives to demonstrate that they are actively pursuing emission reductions. We have developed a method of pulling carbon dioxide from the exhaust of building boiler systems in order to help building owners to develop an emissions reduction program today while we wait for the grid transformation that's about to begin. Next slide, please. Our building carbon capture system is based on a 4-stage process that allows us to separate the major components of boiler exhaust gases, which are water vapor, nitrogen, oxygen, and carbon dioxide. We first cool the exhaust to extract the water vapor. Then we use a pressure swing absorption process that separates the oxygen and nitrogen and sends those gases back to the flue. We then allow the CO2 to be directed to another subsystem that liquefies and stores carbon dioxide. When the on-site storage tank is full, we pump the CO2 to a truck on the street and transport it to a variety of offtake partners that we have developed locally. Next slide, please. In New York City, we have developed several partnerships to utilize CO2 that we capture. First, we're working with a group called Superior Block, which is a concrete block producer in Brooklyn that will sequester CO2 in their concrete products. We are also working with a C2V supporter, Con Edison, to supply them with our sustainable CO2 that will be used in their steam plant for the adjustment of the pH of their boiler blowdown water. And then we're also proud that we are working with another Brooklyn-based group, Air Company, who's a C2V Cohort member alongside of us, who we've met through this group, that they transform CO2 into various ethanol-based products, one of which is vodka based from CO2. All these partners are part of the local carbontech industry that is being developed. Next slide, please. We're very appreciative to be one of the first 10 companies that were selected by the Carbon to Value Initiative. Our experience has been wonderful, and we have met many other like-minded companies and individuals that understand the challenge and are helping to build a very robust carbontech market that will allow us to achieve our global goal of taming climate change. Next slide, please. Thanks for taking the time this afternoon to be part of this event and hearing about the various companies that are involved, and hopefully stick around for the session where we'll have the virtual room and come visit us. And we appreciate your support. Thank you very much.
Thank you, Doug. Really, I can't wait to see more of this stuff installed in how to electrify large buildings. You know, I heard there is quite a few of them all around the world. So I think there's so much potential.
Just a few, Fred.
Just a few, just a couple of thousand, tens of thousands, or hundreds of thousands of them. Yeah. Right. Great. Thank you, Doug. Up next, we have Martin Kaigle, CEO of Carbon Free out of San Antonio, USA. Martin, over to you.
Hi, Fred, and hello, everyone. Yes, I just want to share with you a little bit about Carbon Free and also our experience of being part of the C2V Initiative. Next, please. A little bit about SkyCycle, our technology for carbon mineralization, which offers a complete CCUS solution, starting off with profitable CCU and moving over the next couple of decades to large-scale evolving sequestration. We're focused on capturing CO2 from industrial point source emitters. So that's the CO2 that's hard to deal with in a lot of cases, and certainly isn't going to be dealt with by changes to renewable and energy regimes. We built a SkyCycle plant next to the flue gas, take the CO2 and mineralize it to a high purity chemical grade precipitated calcium carbonate, which has high value and has an extremely lower carbon footprint of nearly 4 times that of conventional precipitated calcium carbonate. Building out in 50,000 ton modular plants. Each plant is able to capture CO2 profitably, so we're not reliant on the carbon taxes or carbon monetization, although that's a nice additional revenue stream for us. And we believe that that is a way to get at the size and profitability, earlier adoption, and expansion of CO2 capture. Next. In terms of our experience and what we achieved at C2V, during the period of the program, we've successfully raised significant funds for the build out of our #1 SkyCycle plant, the first of its kind. And part of the story was developed certainly through the C2V membership, as there's a growing interest from investors, not just in carbon storage or in plays on carbon tax credits, but in carbon to value, where you're making usable product, and the profitability is much more dependent on the products that you're making. We had an open and honest discussion with members of the CLC. I called it lifting the veil. It was much richer and more valuable than just a pitching event, which is much more one way. And that's helped us develop our insights and develop our story, and actually validated our business model of moving forward with build, own, operate. There have been some really great, engaging and informative and at times thought-provoking workshops and the discussion groups. And I think we found that there's certainly, it's already been mentioned by some of the other guys, there's a strength in numbers of working with others pioneering in the same space. And you can't underestimate that. It can sometimes be a pretty lonely and isolated place working in early stage ventures. So seeing that there are other people in the same ecosystem is hugely energizing and empowering. The C2V provided with a great new focus for looking at driving value from CO2 and started a great combination there. And we believe in extending the carbon reduction down the value chain by making low carbon value products like the precipitated calcium carbonate, which will significantly help people in the downstream value chain to reduce their carbon footprint as well. I joined the company 2 years ago as CEO and have changed the direction and brought forward the SkyCycle technology. And C2V was a perfect platform for the first time for us to if you like, put our heads above the parapet and come out with our new proposition. We've also had some great engagement with, and we'll be taking forward with some of the CLC partners. With Fluor, as was mentioned in the introduction, we're working with them now on the design of our first plant. Working closely with Unilever on their desire for low carbon footprint replacement mineral products for their household cleaning and personal care. And they've provided a great deal of support to us. With Johnson Matthey, where we've just begun a conversation on complementing some of their existing technologies. And with the SCG group out of Thailand, looking at capturing their CO2 and actually putting it also into value-added building and packaging products where we can reduce the carbon footprint of those. Next. So finally, what's next for us? We're completing that detailed design. We'll be ready to roll later next year with our first plant. We're building out our entry into commercialization in the following key application areas, which is not solely prescriptive, but the ones that we find are those that are the most likely and willing to be early adopters. The renewable natural gas space, natural gas from landfill, the blue hydrogen, repurposing methane into hydrogen, which also then produces a lot of CO2. We can successfully decarbonize that. And we've just entered an MOU with the largest waste to energy incinerator player in Europe to decarbonize their energy from waste plants. So we want to continue driving the conversation and profile of carbon capture utilization rather than storage, and we'll be planned to be at the forefront of championing carbon reduction value chains through the production of low carbon chemicals. Next. So just to finish off, more needs to be done to drive value out of carbon. We think the C2V initiative should be just the beginning. Delighted to hear that the program is going to carry on for at least the next 2 years. I'd just like to thank everyone involved. It's probably easier to say that rather than mention people by individuals, otherwise I'll miss somebody. I think the program was incredibly well and professionally run, and great for a first-time play in this. So the C2V itself was a startup, and I think it can be pretty proud of what it's achieved. And I look forward to seeing it move on from strength to strength. Thank you.
Thank you, Martin, for the kind words. And I can't wait to actually see some ultra low carbon PCC coming out of your facility one day, and going into all these everyday life products that we use, including maybe one day my toothpaste. So thanks for the work you're doing, and all the best.
Absolutely. Perfect.
Up next, we have Morgan Sparks, who is the Business Development Director and General Counsel at Air Company out of Brooklyn, USA. Morgan, over to you.
Thank you, Fred, and thanks everyone for the opportunity to speak today. You can jump into the first slide, please. So we are Air Company, and we take carbon dioxide, which is captured from the air, and combine it with hydrogen, which we generate from water, to create high purity alcohols. So our reactor, distillery, and facilities are all powered entirely by renewable electricity. Next slide, please. So we take the high purity ethanol that we create through our process and apply it to various different markets. Last year, we launched the world's first vodka made from carbon dioxide. And yesterday, we actually announced the launch of our first fragrance, which you're welcome to check out on our website. Next slide, please. So for every liter of ethanol we produce, we remove a pound of carbon dioxide from the atmosphere. Here you can see the comparison between our utilization technology versus traditional alcohols. As you know, traditional fermentation requires significant land ownership, water usage, and pesticides, all of which are incredibly carbon intensive. Next slide. So we were fortunate enough to be one of the finalists in the Carbon X Prize, and this year we're also announced as the winner of NASA's CO2 conversion challenge, where we're able to transform CO2 into sugar. Next slide, please. So for the Carbon to Value program, we set out to collaborate and learn not only from CLC members, but also fellow startups in the carbon tech space. Next slide. Some of the key takeaways from the C2V program included an understanding of best practices for partnering with corporates, strengthening our carbon lifecycle analysis, identifying public funding opportunities, mentorship on improving our catalysts, and of course, collaborating with corporates and startups in the carbon tech space. So next slide, I just wanted to quickly touch on a couple of those collaborations. Firstly, we were fortunate enough to work closely with Sue Ellis from Johnson Matthey over the past couple of months to refine our catalyst production. We also worked with King and his team from Con Edison, where we were able to successfully reduce the cost of our renewable electricity by almost half, using a combination of solar and wind power. We're currently working with Taki-san and his team at Mitsubishi Chemicals to explore opportunities for utilizing methanol. Next slide, please. So as part of the C2V cohort, we're exploring a potential collaboration with the team at Carbon Quest, as Doug mentioned, for sourcing CO2 from buildings in Manhattan. We think that would obviously be a great storytelling component to be producing vodka in New York from buildings and from CO2 extracted from buildings in Manhattan. We're also working with Patch to purchase carbon offsets for our transport and packaging, and look forward to continuing these relationships. Next slide, thanks. So at Air Company, our goal is to revolutionize the future of alcohols with our technology, and we aim to be the leading supplier of carbon negative ethanol in the years to come. We're thankful for the opportunity to be a part of such an esteemed group, and look forward to speaking with everyone in the breakout sessions. Thank you.
Thank you, Morgan. Personally, I can't wait for the future of alcohol, including some pathways to aviation fuel, which I badly need when I visit my family back in Europe, and I'm sure I'm not the only one. I hear someone is flying back to Australia too, so thank you so much.
Right. Thanks, Fred.
Up next, we're going to have Moji Karimi. He's the CEO and co-founder of Sembita Factory out of Houston, USA. Moji, over to you.
Thank you, Fred, and thank you, C2V, for bringing us all together. You know, throughout this program, one of my main challenges and, kind of personal growth opportunities has been how to go after Morgan and compete with like vodka. And then on top of that, the accent, When I came to US, I was in Louisiana for 2 years, so that's how I learned English. I have this kind of Cajun Persian mix, but I'm gonna do my best to see if I could top Morgan. So Cemvita Factory, we are on a vision, on a mission to bring low carbon solutions to the chemical industry. We have a special focus on petrochemicals and replacing fossil fuels with flue gas or CO2 as a feedstock. And of course, this is a special focus around the U when we talk about the CCUS, which is another part of really what I really loved about the C2V program, is because, all the companies that you see today, we've been spreading the message for utilization as opposed to just storage. And maybe at times we felt alone in that message. There's still a lot of places where they just say CCS, they don't say CCUS. So C2V brought us together and kind of made this message more coherent. So we'll really look forward to building up on that and help companies utilize CO2 than just wasting the carbon by just storing it. And next slide, please. So basically what we're doing at Cemvita is thinking of microbes as a small chemical plants. As you know from fermentation, microbes eat something and produce something. We're all familiar with the fermentation process using sugar to make alcohol. It's about time that we could program microbes to eat CO2 instead of sugar and produce other chemicals instead of just alcohol. So the vision for Cemvita is to basically be able to use flue gas directly as a carbon source and a feedstock for conversion to other chemicals. We have a special focus on precursors to polymers and plastics, and we have a list of about 30 different chemicals that we could make from CO2. A fundamental problem that we've also solved is not needing hydrogen independently, because that's what really eats into a lot of the carbon savings, depending on how the hydrogen is produced. But our microbes could start basically with CO2 and water, and then the water splitting reaction happens inside the cell. Next slide, please. So when we joined the C2V program, really what we're looking for was clients and partnerships, policy, and collaboration. And I'll touch on the three of these aspects. For clients, we had a lot of good discussions with different CLC members and understanding what is the fit. One that stands out is Suez. We had a really good discussion, which we're still continuing. Part of also us not having announcements during the program was because we're already working with some of the other CLC members, which goes to say the fit between the companies and the members. BHP is already an investor at Cemvita and a customer. Johnson Matthey, Mitsubishi, we've had discussions with Fluor, and we'll continue on to also explore how we could help bring our technology to life in collaboration with the other CLC members. On the policy side, CCUS is very complex, so there's been a lot of discussion, and through the work in meetings with Carbon 180, they really helped us in thinking about that and taking the next steps in being more involved on the policy and its influence on our technology. And of course, collaborations. We really enjoyed working with the entrepreneurs, the mentors that they were assigned to us for different areas. And actually one of those led to a partnership with the University of Columbia, which we're launching now. So we're very grateful for the advice there. Next slide, please. So what's next? I think, Fred mentions that he can't wait for these technologies. And I think everyone feels the same way. And that goes to scale up, right? So everyone wants to utilize all this momentum for scale up of this technology. So that's also what's next for us. The project that we have that's ahead of others is the bioethylene project with Oxy, but we have others right behind that. And in our own scale up facility, we're also doing up to 1,000 liter for boiling down basically the microbiology to process engineering and build an Aspen model. So then we could have a better relationship and discussion with EPC companies and our clients. On the corporate side, I think a lot of what this startups brought to the table is to think about different ways to accelerate R&D. It doesn't always make sense to do a lot of this work internally where startups could help accelerate the process. So that's an opportunity area that we'd like to explore further. And then of course, on the collaboration side, it's just in the name with CCUS, there's emitters, there is carbon capture, and then there's the utilization. So there's a lot of room for collaborations, and we look forward to working with the other startups in the program and the CLC members post-program to bring that to life. In some ways, it's today is bittersweet because it's the end of the program, but it's also the start of this next phase of graduating and working with the other companies involved. I think that's my last slide, and thank you so much for your time, and I'll be sticking around for questions and getting to know all the other members of the audience.
Thank you, Moji. You're right. I can't wait again just to see more intermediate chemicals like made out of CO2 using smart biology as a service business model. I think the company you're building is really very interesting, and look forward to staying in touch. Thank you, Moji.
Thank you.
Okay, let's take a break from the startup presentation, and we do have Emily Gruber with us. Unfortunately, I think she is experiencing some technical issues. So we're going to give it a try live. We did test that before, but apparently some parameters changed. So let's give it a shot. Emily, can you hear me?
And hello.
Awesome, great. So it looks like everything works well. Well, thank you so much for joining. I just want to introduce you a couple of minutes. So it's a pleasure to welcome you. You're the Deputy Assistant Secretary at the Office of Carbon Management at the US Department of Energy. You're a civil engineer and environmental sociologist who studies and informed decision-making regarding infrastructure systems, and particularly related to justice centering decarbonization of the US energy system. Your expertise includes studying the life cycle of and socio-environmental impacts associated with the future policy and infrastructure. In your role at DOE, you focus on technologies like carbon capture, carbon dioxide removal, CO2 conversion into products, and reliable CO2 storage. So I think we couldn't have dreamt of a better person to have a chat today. And so thank you so much and welcome.
Thank you for having me.
Great. So yeah, I think what we could start with is maybe you could remind us a little bit about the overall climate agenda of the Biden administration, and compared to what was the previous goals, are there any new specific goals that it sets?
Yeah, certainly. So I'm with the Office of Fossil Energy and Carbon Management. And as Frederick mentioned, I'm the Deputy Assistant Secretary for the carbon management side in particular. This is actually a big change for us. So for the first time since the Office of Fossil Energy was created, we actually have changed our name. And so as of July, carbon management is a core part of what we're doing in a very explicit way that leads with our name. This builds on work that we've been doing for 20 years or so, but now is really being centered in the way that we're thinking about our research and development activities. So I think one of the core reasons why we are so focused on carbon management and so focused on some of these technologies is because of administration goals, including 50% reductions in greenhouse gas emissions economy-wide versus 2005 levels by 2030, a fully decarbonized electricity sector by 2035, and then ultimately net zero greenhouse gas emissions economy-wide by 2050. So our role is both in kind of the existing infrastructure side of things on power plants, industrial sources, and those types of things, and then also really looking into long-term carbon dioxide removal technologies that we anticipate needing to hit net zero goals by mid-century.
Great, yeah, very impressive. And so when you look at these very high-level targets, does that translate into more specific goals in your Office of Carbon Management?
Yeah, also a great question. So one of the things that we are really focused on when we're thinking about how our R&D priorities shake out is really whether the work that we're doing gets us on a path to net zero emissions long term. So we want to be able to provide a lot of information to the public and really leverage our status as an R&D organization to gather data that's important for understanding how carbon management works. As part of that, the way that we're thinking about the types of information that we need to gather and the types of things we actually need to test is really whether these are compatible with long-term net zero goals. We have some things, particularly in my sister office, the Office of Resource Sustainability, which is also in fossil energy and carbon management, that are really focused on near-term resource sustainability issues. So things like methane mitigation. On the carbon management side, though, we really do think about how we ensure that the technologies that we're investigating put us on a path to net zero. So that's not just technology deployment, but also a lot of analytical work and some strategic analysis that we do to evaluate how we might expect these technologies to exist in a net zero world.
Great. And maybe I think for the audience, we could just take a step back and maybe define, carbon management. What do you include in it, and maybe the difference with carbontech? How do you see that?
Yeah, also a great question. So we've been thinking a lot about this because there's a lot that falls under the umbrella of carbon management for us. I think two of the major dynamics that we look at when we think about what carbon management is essentially whether we're focusing on mitigation, which tends to be sort of the conventional mitigative point source carbon capture, utilization, and storage types of techniques that we might put on existing industry, like a cement plant, and potentially in the power sector. So we're working in particular on potential CCS applications in natural gas power, which is a bit of a new area for us. In addition to that mitigative point source carbon capture and storage work that we do, we really are also looking at techniques to evaluate and enhance carbon dioxide removal. So distinct from mitigative emissions in that carbon dioxide removal removes CO2 that's already in the atmosphere. This is a technology and a set of pathways, really. It's not just a technology, and not everything that we're looking at is necessarily technological, but these are approaches that we see as potentially promising for actually removing emissions from the atmosphere, either that we could not avoid emitting or failed to avoid emitting, or to address legacy emissions in the atmosphere long term. So if the goal right now is net zero emissions by mid-century, we anticipate that we'll probably get to a point where maybe net negative is on the table. For those types of things, really thinking about carbon dioxide removal as another strategy is a big part of what we do. But we have been trying to be pretty careful about distinguishing between the mitigation approaches, because mitigation is the core goal. Net zero is much, much easier the closer you get to zero, and we're very focused on getting to zero and really trying to use what we can provide to inform pathways to get to zero. And then in addition, really thinking about removal from a very diverse set of techniques. So not just the technological things that are more consistent with maybe what you've heard about carbon capture, like direct air capture and things like this, but also biologically based approaches like soil carbon sequestration. We don't tend to use the term carbontech as much, but I'm always really, really interested to see people using that in practice. And we're really curious to see how some of that plays into this space as well, because we do have a carbon utilization program, and we recognize that some carbon utilization is removal and some is mitigation, some is avoidance and offsetting as well. So very interested to see some of those technologies coming out.
Yeah, and do you have a sense of how much of your net zero goals rely on carbon management, whether it's like mitigation or carbon removal? I think for general audience, it's always a little bit conflicting. You're like, should we like focus on reducing emission? Why should we remove carbon from the atmosphere? It's necessarily the either or, but I think reminding what is the role basically of carbon management into broader other climate strategies like electrification. There is a lot of stuff we can do beyond carbon management.
Yeah, certainly. And I think we really see ourselves as trying to provide information that informs some of those pathways to net zero. We don't see ourselves as technology advocates, but rather as technology evaluators. And so recognizing that maybe there is a path for CCS if people continue to use fossil fuels, we want to make sure that that technology is understood and that we know basically how to put ourselves on a pathway to just and sustainable deployment of mitigative CCS. We also know that based on a lot of the modeling that we see globally and domestically, really thinking about net zero as something that relies on removal at some level, because either you're zero or you have some positive emissions and you actually need some net negative. We see ourselves as basically taking the role of really investigating whether these technologies and approaches are available to us. So we try very hard to structure our programs in a way that provides information about whether these things are useful, what they do, how they work, what their costs are, and really think about ourselves as de-risking them by essentially reducing uncertainty. In some cases, that may mean that we move on from some technologies, and particularly as we're starting to move more into the carbon dioxide removal space, we've been thinking a lot about where we really draw the line as how we're sure that something is meeting a performance standard or not. But our role goal really is to try to support the overall decarbonization transition. In some cases, that may mean really making sure that we're available and waiting, but not necessarily deploying in a really significant way. But we do believe that, especially based on a lot of the efforts around net zero, that carbon dioxide removal in particular is going to be pretty key, and also that in a lot of industrial applications where mitigation is essentially dependent on carbon capture, so particularly with technologies like cement, where you do have process emissions of CO2, even if you get the fossil energy out of those systems, we really anticipate that having these technologies available, waiting, and ready to go is going to be quite crucial to success.
Yeah, and maybe also for the startups and the corporates in the room, is funding the primary role of DOE? What are the different roles that you want to play? And also with regards to R&D demonstration and deployment investments, and maybe also looking at the prioritization of different technology pathways. And are you focusing on earlier stage or later stage? Where do you draw the line between where DOE wants to really heavily support and where you think maybe the private sector then is supposed to kind of take over gradually the tech to market?
Yeah, that's a great question too. And I will say I can't speak for DOE entirely. I'm still relatively new to the organization. And I know a lot of the other offices are actually engaged in stuff that we don't necessarily do in the R&D arm, which is where I am in carbon management. So organizations like the Loan Programs Office actually are a bit more focused on grant making and some of the big deployment areas. We're also all kind of eagerly awaiting news to see what the infrastructure bill might look like. So that has some more emphasis on deployment than we maybe historically have had. But at least from an R&D perspective within carbon management, we really think about priorities in terms of what's going to get us to these long-term goals, as well as where we think that it's likely that we're going to need a little bit of extra information before there might be uptake. And so to the extent that we can de-risk technologies and really invest in areas where we don't see other activity taking place, but we suspect that these technologies may be important, we think a lot about what our role is and where we can fill gaps. And so I think particularly as we think about how companies are playing in this space, we've been working a lot on trying to understand what our role is in filling some of those gaps. And again, making risks, costs, and other uncertainties transparent with our efforts. So really trying to leverage what we can do to provide as much information as we possibly can to be helpful.
Yeah, because everybody thinks, about the kind of the climate impact, but there is also a lot of data beyond like the cost and the climate impact, like how do you assess, for instance, social environmental consideration beyond climate impact when you look at different projects?
Yeah, absolutely. And that's a really, really core area of what we're working on, is really trying to understand some of the environmental justice implications of these technologies as well. So clearly we're testing out the technologies and we're trying to understand how technological deployment works, where we need innovation in those spaces. But we're also really trying to understand what innovation might look like in governance and institutional structures and how these types of technologies exist in a socio-technical context. Some of that is really evaluating things like scale and how things integrate into particular host sites and things like this. Part of it is also really trying to understand what the co-benefits and potentially disbenefits of different technologies might be, so that we can match technologies to the most responsible deployment that we possibly can. And so a lot of our data collection does focus on things like trying to understand what other air pollution benefits or disbenefits might be, some of the life cycle implications of a lot of this work. So we're very focused not only on techno-economic analysis, but also life cycle assessment as we move through these processes. And then also really trying to understand what the overall context of these things are as systems. And so part of what we're kind of thinking about is, where do we need additional social science in addition to some of the physical science and engineering that we tend to focus on as well?
Yeah, no, that's so important. And maybe we can also explore a little bit, from your perspective, from what you're seeing through the projects you're supporting and the activities you're doing, some of the gaps or like barriers to carbon management that you're seeing that needs work.
Yeah, so one of the ones that's near and dear to my heart, because I basically have come to DOE from a role as a civil engineering professor where I work on life cycle assessment. One of the things that we work on a lot within my office is trying to understand the carbon accounting behind these things. And I think one of the major barriers to good carbon management is really understanding in a very rigorous way what's going on, particularly as we're moving into additional work on carbon dioxide removal. Recognizing that different approaches have actually very, very different analytical challenges has been something something that we're quite keen to understand and quite keen to be a resource for. So thinking about, a purely technologically based DAX project or something, direct air capture with storage, relative to something like soil carbon sequestration, where you analyze what the timelines are, the temporalities, and the various spatialities of these things as well, actually does really affect how you can really claim whether you've met a performance standard or not. So we're trying very hard to understand those things in a rigorous way. And then also with our projects themselves, we're thinking a lot about using simulations, AI, machine learning, those types of things, in addition to a lot of our other more conventional lab work, to really try to understand where the pain points might be, so that once we do put things out into the field, we know what we need to test and what we know the sensitivities might be. So thinking a lot about just basically how do we stress test these systems to provide as much information as we possibly can about how to overcome some of the barriers if the technologies are called upon.
And how do you work with, like, let's say a startup? Do they have to apply, or they can contact you and say, I have a novel, like seaweed carbon removal solution. How can you help to kind of account the carbon and give them some guidelines? What are the main ways of engaging, let's say, with private sector innovators?
Yeah. Great question as well. So one thing that I've been telling people a lot, because not everyone realizes this, if you request a meeting with us, we will consider that. And we often do take meetings just to talk through technologies and talk through people thinking about their analytical approaches, how we think about it, those types of things. So we're very happy to have a meeting. One of the things that I've been saying to a lot of people as well lately is that we really do appreciate also getting critical feedback. So if you have something that you see us doing that you're concerned about, set up a meeting and we'll see if we can talk in that context. I think more generally too, once we have things like funding opportunity announcements, we're not necessarily able to talk about those, but prior to a release of a funding opportunity announcement, we can talk broadly about technologies and kind of think about some of the ways that those integrate with our programs. So I know lately we've got a couple of notices of intent out, one on direct air capture for basically coupled to low carbon or zero carbon energy. So that one is out on the street. And I think we are thinking a lot about very interesting and exciting opportunities going forward. But yeah, we're very happy to take meetings.
Great. So I think the word is out there for all C2V companies and all the entrepreneurs in the event today. I know it's a challenge. It's been one of the major also barriers that we've identified with C2V, the carbon accounting. And I mean, it's just going to be case by case. And sometimes I think policy can also help to set the standards, like we're seeing with 45Q or LICLA in New York. I think the time is running, but maybe we should dedicate 1 or 2 minutes about if you had key messages, maybe you wanted to leave the audience with, or reflection, what would it be?
Yeah, I think the core one is we recognize carbon management as a really critical role for the Department of Energy to play. And I think what we're really driving toward is how we can leverage these technologies to move toward a more just and more sustainable future of net zero emissions. So this is really, really core to what we do. And we're very, very honestly obsessed with making sure that we're doing this as well as we possibly can. And so especially because we're kind of at the beginning of an industry in a lot of ways, we're always very interested to get feedback and really trying to do a great job. So thank you all for spending some time with me tonight. I really appreciate the opportunity to join you.
Yeah, well, we appreciate that you were able to join us. And so it's just really interesting to learn more about the work DOE does in this field. And we really look forward to more collaboration with not only with the US federal government, but also with other international government around the world. It's something that C2V also can provide and can convene, if you will.
Thank you.
Thanks, Emily, for joining. Really was a pleasure.
Absolutely. Good night.
Yeah. Great. And a quick reminder for the audience, we still have these quiz questions, top right-hand corner of your screen. You can test your carbontech knowledge and we'll get the right answers at the end. But with that, we'll move on with our next speaker, who's going to present and talk a little bit about Mars Materials. Aaron Fitzgerald, who's the founder of Mars Materials out of Oakland, USA. And Aaron, it's over to you.
Thank you, Fred. Hi, everyone. Aaron Fitzgerald here. I'm the CEO and co-founder of Mars Materials. At Mars, we're working to sequester a gigaton of CO2 back into the supply chain for use in everyday products. Today, we're commercializing nitrylation, which is NREL developed carbon tech that enables us to produce the raw material for carbon fiber and other materials. Our technology enables us to produce this material cheaper, with fewer emissions, and using captured CO2. Next slide, please. Carbontech is interesting to Mars because of its ability to sit at the nexus of decarbonization and carbon removal. We're creating a commercialization sweet spot where we're able to transition long-lived product markets with exceptional growth potential to using captured CO2 as feedstock. And we see financial opportunity here too. Scenarios on screen highlight Carbontech's exceptional use potential of captured CO2 by 2050. Next slide, please. We're currently a team of 4, including 3 chemical engineers. Guiding us along the way is our lab partners at NREL, carbon and value mentors like Mitch Tyson and Jim Stover, and other mentors and advisors representing firms like Carbon 180, NYSERDA, Google Ventures, and others. Next slide, please. Oh, next slide, please. Acrylonitrile is a $12 billion chemical market. Oh, back one, please. Thank you. In addition to its use as the raw material for carbon fiber, acrylonitrile is used in consumer goods like electronics, carpets, vacuums, and toys. It's also used for buildings and industrial use. Acrylonitrile's use is growing in many areas, but its largest opportunity is in carbon fiber, where it takes 2 tons of acrylonitrile to make 1 ton of carbon fiber. Carbon fiber is used to make airplanes, sporting goods, and buildings. And lower cost and carbon neutral carbon fiber can be used as a direct replacement for steel and aluminum. These hard to decarbonize materials are responsible for 11% of global emissions. Mars joined Carbon of Value to learn how we can partner with carbon fiber manufacturers and get to market quickly. Let me show you why we're so eager to bring our technology to market. Next slide, please. Nearly all acrylonitrile is produced from petrochemicals. Coming in Carbon of Value, we learned that the conventional process is expensive, it's unreliable, and it's dirty. Nitrilation can grow the acrylonitrile market and clean the air. Our units produce acrylonitrile 33% cheaper with 57% less capex, and it saves a kilogram of CO2 per kilogram of acrylonitrile produced. And here's how our patented process works. Next slide, please. Goodbye fossil fuels and goodbye atmospheric carbon. Our process takes CO2 from the air and industrial point sources along with bio-based inputs and converts it into acrylonitrile. Our acrylonitrile is molecularly the same, but as we've learned during discovery, we don't have the scale yet for carbon fiber manufacturers. Next slide. So we went on a discovery to identify a market that's ready for our technology today, with the eventual plan to expand into carbon fiber. As you can see, there are many markets for acrylonitrile. Look around you, your keyboard keys, your clothes. It's likely made from acrylonitrile. We needed to find the right entry point. Next slide. So using Carbon of Value CLC members, we set out to conduct discovery and de-risk our supply chain, scale up and scale out plans. Over the course of the program, we met with all corporate CLC members that you see here, and we learned which members use acrylonitrile in their supply chains. This discovery spiraled, and we uncovered other nuances to the acrylonitrile supply chain. We also learned about the acrylamide market. Acrylamide is a $4 billion polymer market. Acrylonitrile is acrylamide's sole raw material. So when you polymerize acrylamide, it becomes something called PAM, and it's used to treat wastewater. Effectively, it's a glue that binds to solids in wastewater to purify the water. How cool is that? But PAM is used by nearly every wastewater treatment facility around the globe. So acrylamide manufacturers have shared that they're actively looking to diversify their acrylonitrile supplier base, and Mars's technology is interesting to them. So we've been working to produce samples for these manufacturers. Next slide. And we're learning from others who have been where we are today. Fellow cohort members shared their experiences and insights with us. We also found future potential supply chain partners with a couple cohort members as well. And that brings me to what's next for us. Next slide, please. Today, I'm really excited to share with the Carbon and Value community that we're expanding our team. We're looking for a talented process engineer to join our scale-up team, and all are welcome to work at Mars. We're also raising a pre-seed round. We're looking for investor partners with interest in climate tech, supply chain technologies, green chemistry, and those interested in supporting minority founders. And finally, if you're familiar with the acrylamide market or carbon fiber markets, reach out to us. We have knowledge gaps, and we'd like you to help us fill them. Next slide, please. So in closing, I just want to thank the Carbon and Value team, CLC members, program supporters, and my fellow cohort members for supporting us. We're getting closer to our vision to remake the built modern world and captured CO2. Thank you for your time and listening to this, and we look forward to seeing you at our booth. Bye.
Thank you, Aaron. I can't wait to see more of Mars carbon fiber conquering the world. I think we'll need it with all these electric bikes and electric cars. So you're on a way to growth. It's amazing. Thank you.
Thank you, Fred.
Up next, we have Alex Ip. Alex is the co-founder of CERT out of Toronto, Canada. And Alex, it's over to you.
Thank you very much, Fred. And thank you to the whole Carbon to Value team. It's been an amazing journey over the past 6 months, and thank you to everyone for joining today. So my name is Alex Ip. I'm co-founder of CERT. At CERT, we've developed an electrochemical technology to convert carbon dioxide into renewable chemical feedstocks and fuels. Next slide. Here's a look at our founding team. Christine Gabardo joined our team, and she's an expert in electrochemistry and scaling up electrochemical devices. She has a background in biomedical electrochemical devices, and she's really helped to scale up our technology. She led our efforts in the Carbon X Prize, where we were a finalist last year. For myself, I was growing this research group in carbon utilization over the past 5 years, raised over $12 million towards the R&D, some of which went into CERT. Next slide. And so the problem that we're trying to tackle at CERT is the fact that we're using a lot more products, but if we continue going the same way that we're going now, as you can see here, the emissions are just going to continue increasing as demand for these products increases and increases. And a big problem with that is actually right at the front end, the basic building blocks that go into these products, such as plastics or textiles or other materials. The way that we make them now is heavily emitting. Next slide. In fact, the chemical manufacturing industry creates about 1.5 gigatons of CO2 every year. And despite the fact that there's been a huge push for decarbonization, right now it's really difficult to decarbonize these processes because they require high heats, lots of combustion of fossil fuels. It's very difficult to electrify them. This is really unfortunate because, as you see on the next slide, the cost of renewable electricity has come down significantly over the past 10 years. It's really kind of one of the miracles in clean tech, just how fast that price has come down. But chemical manufacturing can't really take advantage of that. And that's where we come in. Next slide. We developed this electrochemical technology that can take renewable electricity, as well as water and carbon dioxide sourced either from the air or from a flue gas point source. And we basically have developed a new catalyst electrode that can split that CO2 molecule and reform it into various sorts of chemical feedstocks. So it looks similar to a hydrogen electrolyzer where you'd be splitting water, but we developed new materials that allow us to split the carbon dioxide molecule instead. And we can develop a number of different products from them. Next slide. In particular, we're very focused on these multi-carbon products. So ethylene is one of our major targets. It's the most important petrochemical in the world. It's about 200 million tons of annual production and about a $200 billion market. And so there's lots of opportunities there for decarbonization. We're also looking at products such as ethanol, which is a clean liquid fuel. A lot of use of that in gasoline blending, as well as other chemical manufacturing uses. Next slide. Electrochemical technology. One, it's a modular technology, and so you can scale up the number of reactors just by multiplying those reactors out, and basically allow you to adjust to the scale of the CO2 that's available or demand for your end product. There's a high embedded CO2 in that final product. All the carbon is coming from carbon dioxide molecules. We're not just inserting, a CO2 atom here or there. And furthermore, you're actually embedding 3 tons of CO2 into every ton of ethylene that you make. It's a drop-in replacement for fossil-based chemicals. We're not making a similar product. We're making something that's exactly the same, and so all the downstream processing can remain exactly the same as it was. The difference is, of course, is that ours is renewable. Next slide. And so we see ourselves working with conventional petrochemical manufacturers, where today ethylene is produced from a steam cracking process, and that emits a significant amount of CO2. Then the ethylene is then sent down towards different sort of ethylene derivatives and products. Next slide. So in our case, we would like to capture that CO2 and then convert it into ethylene and feed it back into the existing infrastructure for taking that ethylene and converting it into different sorts of products. As I mentioned, you end up consuming 3 tons of CO2 for every ton of ethylene that you make. And this provides us with a pathway towards over a gigaton of potential annual reductions. Next slide. And this isn't just a concept or something in the lab. We've actually done a significant amount of work in scaling it up. As I mentioned, my co-founder Christine really led this effort in the Carbon X Prize, where we took the carbon dioxide from a natural gas power plant in Alberta, and we converted that CO2 into ethylene and syngas on site. Next slide. This demonstration was the largest CO2 electrolyzer demonstration so far, and the first one to convert CO2 to ethylene at scale and from an industrial CO2 source. So we've come a long way from where we were even just a few years ago in the lab, and shown that we can really scale up this technology. Next slide. Yeah, and that the X Prize wrapped up at the end of 2020, and that's shortly after that we joined the Carbon to Value Initiative, and it came at a really great point in our company's development. We were really looking to build up the corporation, make new partnerships, and that's really what we were able to do. We besides connecting with the cohort members, we were connected with many members of the CLC, and were able to find ways that we could partner with them, not only to help with the development of our technology, but also identify new ways to go to market. And so moving forward, we want to continue a lot of those conversations. Next slide. Or further partnerships from anyone here in the audience, please do come talk to us at our booth later. We're looking for further help on scaling up, strategy for bringing our product to market. And we're expecting to open a funding round in early 2022 to raise some seed funding. So you can email me there, or please, again, drop by our booth. Once again, thank you so much to the C2V group and the C2V team for bringing us through this last 6 months. Thanks very much.
Thank you, Alex. Yeah, I can't wait to see more low carbon ethylene made from upcycled CO2 instead of fossil fuel. So good luck to you and to Christine and all the team at CERT for the next steps. Up next, we have Jason Weiss. He's the Director of External Relations at Planetary Hydrogen out of Dartmouth, Canada. Jason, over to you.
Great, thanks, Fred. So I'm very pleased to be here with you today to talk about how C2V has really accelerated our progress over the last 6 months. At Planetary Hydrogen, we are on a mission to remove a gigaton of carbon directly from the air while restoring ocean chemistry. And as most people know, or a lot of people know, climate change is having a disproportionate impact on the oceans, which have absorbed about 90% of the excess heat and a third of the emissions emitted, leading to devastating impacts on marine ecosystems. However, the oceans also need to be part of the climate solution. They're the largest reservoir of carbon on the Earth's surface, with the potential to store billions of tons of carbon annually. And that's where our ocean-based CDR technology comes in. Next slide, please. But as our name suggests, our focus was on the production of carbon-negative hydrogen as a means to access high-value carbon credits on the compliance market. This ultra-green form of hydrogen can be used to lower the carbon intensity of traditional fuels by replacing dirtier forms of hydrogen as a feedstock for clean synthetic fuels. And these fuels will be required to decarbonize the 20% of our energy system that cannot easily be electrified, so applications such as aviation and marine shipping. But working with the carbontech Leadership Council and through Carbon to Value is really how we were able to develop a pathway to achieving this goal. But first, I'll just give you a quick refresher on our technology. Next slide, please. So our process uses saline electrolysis to produce hydrogen in a mild form of alkalinity using water, renewable energy, and a mineral feedstock. Next slide. This low carbon alkalinity can be used to enhance the ocean's natural process of converting dissolved carbon dioxide in the surface ocean into stable carbonate and bicarbonate, and then storing it in ocean chemistry for over 100,000 years while countering local ocean acidification. Next slide. So essentially, we are accelerating the natural rock weathering process that has kept climate stable for millions of years while harvesting the byproducts, mainly hydrogen. So next slide, please. So for us, why Carbon to Value? Really, we had 3 goals from participating in this initiative. We were looking to refine our go-to-market strategies, as I already alluded to. We wanted to gain exposure to and potentially identify a strategic partner or partners who we could work with to advance our technology development. as well as develop a robust approach to influencing policies favorable to advancing our climate solution. And really what we got was a very transformative way of looking at how we develop our technology. In fact, if you go to the next slide, through the Carbon to Value Initiative and working with our mentors at Greentown Lab and NYSERDA, we've really refined our go-to-market strategy and have developed a technology roadmap that includes 4 different generations. We've concluded that the demand for high-quality durable carbon removal credits on the voluntary market is sufficiently high to fund the piloting and scale-up of our process, at which point our green hydrogen and other value-added byproducts can play a bigger role in bringing down the net cost of these removals. So like I mentioned, we've broken down the development of our technology into four generations. Thank you. And really we're focusing on certifying or verifying those carbon removals within the surface ocean, as well as producing that low carbon alkalinity. And now we can move to the next slide. So as I mentioned, 2 primary activities. So the measurement, reporting, and verification of carbon we capture in the surface ocean, as well as the production of low carbon alkalinity from mine tailings. And on the verification side, we've been working with researchers at Dalhousie University on a multi-year research program to develop MRV protocols, while also looking at impacts on marine life. So that's the image there on the left. And discussions with CLC members have really informed our approach on how we can leverage this work to accelerate third-party certification, as well as lay the groundwork for further collaboration. And it's actually led to working with wastewater treatment facility in the UK, as well as in Dartmouth, where we're going to initiate real-world measurements and testing to support this. And on the production of low carbon alkalinity, we're actually now working with 2 different mine sites testing tailings, as you can see on the right-hand side. And this has actually led to a partnership with a mining company in South America, where we're doing some of this work. So on the next slide. So to summarize our top 3 accomplishments, I'd say we've refined our go-to-market strategy and identified iterative generations of our technology to take us from lab to commercial scale, focusing on ocean CDR, measurement, reporting, and verification, as well as the production of this low carbon alkalinity. And we've received validation of this approach by securing a mining partner who we are working with to integrate our electrochemical process with their existing waste stream. And we've set a clear path for CDR, ocean CDR certification. And recently we're actually recognized with a prize with the Ocean Startup Project Challenge, which is going to help to accelerate that. So the last slide. I'd just like to say, it's been a real privilege to work with such a passionate group of people dedicated to addressing humanity's biggest challenge yet. It's been said before already today. I think this is just the beginning. We're really looking forward to fostering and developing these relationships further. And we encourage you to stay tuned and gear up as we gear up for a future funding round. And we're also hiring, so come see us in the booth later if you're around. Thank you.
Great, thank you so much, Jason. I can't wait to see massive amounts of carbon sequestered into the ocean, while at the same time producing a clean fuel. That's awesome. Thank you for the work you're doing with Mike and all the team at Planetary Hydrogen.
Thanks, Fred.
Great. Next up, we'll have Christine Ingi Laursen. He's the head of business development at Carbfix, and he's based out of Reykjavik, Iceland. Christine, over to you.
Hello, everyone. My name is Christine Ingi Laursen. I'm head of business development at Carbfix. Next slide, please. So we are seeing here quite extraordinary and extreme figures. The annual CO2 emission for the last 50 years has risen significantly, currently approximately 35 billion tons per year. It's estimated also that the carbon capture and storage / utilization market will be approximately 115 gigatons in the coming 40 years. Next slide, please. So Carbfix, what we do, we capture CO2 directly from the source. We also turn the captured CO2 into stone underground in less than 2 years through our proprietary technology that imitates and accelerates natural processes. On this picture, you can actually see basaltic rock that has the solid carbonates in it, the white spots. Please, next slide. This process itself is relatively simple. What we do, we mix CO2 and water together. Usually the rule of thumb is 1 of CO2 and 25 of water. We then inject that water, CO2, into the ground, where it starts to mineralize below ground and becomes a solid carbon. This process takes less than 24 months. Next slide, please. This is a simple schematic of our operation plant here in Iceland, Hellisheiði, where we actually take the emission directly out of the source. We mix it in a scrubbing tower with water, where we then inject it into the injection site and into the ground, where the mineralization starts to take place and the stable carbonate becomes or happens. So far, we have injected approximately 100,000 tons of CO2 into the ground, and the limiting factor is actually access to CO2. This entire value chain, that is the capturing, the transport, as well as the injection, is less than $25 per ton. Next slide, please. This is not only limited to Iceland. Basaltic rock is actually one of the most common rock formations in the globe, covering approximately 5% of the earth or land, and also the majority of the ocean floor. It's estimated that Iceland alone can store approximately 2,500 gigatons. North America is estimated approximately 7,500 gigatons. So we're talking about some extreme numbers. Next slide, please. We at Carbfix have developed or decided to go 3 paths forward in our global scale-up. This will not only be in Iceland, this will be on a global basis, and our scale-up is based upon that. The first one being an on-site capture and mineral storage, similar to the one that we have at our facility in Iceland, where the geological conditions are favorable and the emitter has access to CO2. If the emitter has not access, or let's say for positive geological conditions, we would opt for the transport to mineral storage hub, the one that's marked B. This is actually a hub that we just recently announced. We will call it the Cohort terminal, and we foresee to build this particular terminal in Iceland in the coming years to be launched in 2025. And when it reaches its full maturity in 2030, it will be the world's largest mineral storage site with 3 million tons injected on a yearly basis. The last one is the direct air capture and mineral storage, which we have just recently launched with our partners from Switzerland, Climeworks. And then we receive the CO2 and inject it into the ground. Next slide, please. So why mineral storage? It's a natural way, nature's way of storing carbon. It's very economical, it's safe, it's innovative, it has almost unlimited storage capacity, and it's a permanent storage. Next slide, please. So going forward, we are scaling up. We are scaling up on a global basis. In every continent, we are seeking global partners, not only in North America, but across the globe. We are currently consulting the world's largest organizations in their voyage forward, and we will license out our IP rights going forward as well. We will continue to develop our offshore applications instead of using freshwater, being able to use seawater, and we will also explore other geological formations. Our ultimate goal in the next 10 years is to reach 1 gigaton. I think just at the end, I would like to thank everyone who has participated with us, and we are extremely happy and pleased, and so please contact us if you have any further inquiries. Thank you.
Thanks, Christine. It's been really cool working with you, and I just can't wait to see Carbfix next site being deployed in North America. We're waiting for you, so you're welcome. And just also seeing the CO2 being permanently sequestered, I think that's really a key attribute of your solution.
Thank you.
Great, and we have our next and last entrepreneur of the day, Elias Erlheimer. He's the partnership and sustainability lead at Patch out of San Francisco, USA. Elias, over to you.
Thanks, Fred. I don't think I've ever been called an entrepreneur, so I appreciate that. Next slide, please. And next slide again. So at Patch, we're building a marketplace, API-first marketplace for carbon offsetting and carbon removal. What that means by what I mean by API first is we're really focusing on building the infrastructure to allow our customers to build in carbon offsetting and carbon removal into the applications that they use or manage. We connect these customers with a variety of carbon removal or carbon offsetting options and allow them to build portfolios as well as different use cases like banking and payments, logistics, e-commerce, and travel. Next slide, please. We ingest a variety of data into the platform in order to help our customers make an informed decision on the projects they want to choose to contribute to. The API also has the ability to estimate the carbon emissions with a given activity. So it spits out an amount of volume of tonnage, and then the customer gets to build in which projects that are contributed to. Next slide, please. So some of these use cases include like a carbon neutral credit card, where the emissions for every purchase are calculated. We're working with a variety of brands like companies that are plugging into Shopify stores and allowing companies as well to offset their corporate emissions, so their back of house emissions that they've already calculated. Next slide, please. So we had a variety of motivations to participate in the C2V initiative. As a software company, we're a bit different than the rest of the organizations involved in that we're the connector, allowing companies like our cohort members to help them commercialize and sell the carbon credits that they may be generating. We want to connect with early movers, both on the cohort and startup side, as well as on the customer side, ones that want to build in applications that help neutralize everyday activities or purchases. We also wanted to learn from our suppliers to understand what kind of pain points they have, and then build software to solve those issues. Next slide, please. We had a variety of achievements and learnings throughout. We were able to develop a strategy by interviewing our cohort members to build these software solutions. And so we actually started to build out our supplier experience, which includes inventory management, as well as white labeled solutions to allow our cohort members to actually go out and sell on their own. We also fostered new connections with a variety of customers and early movers in order to continue building new applications in the space. Next slide, please. And then as for what's next at Patch, we're hiring, and we're trying to hire aggressively. So to call out, we have I think over 15 openings on our site right now. We just raised our Series A, and so we're trying to aggressively deploy this capital. So please reach out if you're interested in any of the positions we have open. We also would love to continue to build relationships in this space, especially with organizations that are removing carbon from the atmosphere and wanting to commercialize the sale of these credits that they are generating. And yeah, I just appreciate everybody's support and time throughout the program. It's been a blast, and I look forward to all the success that everyone has in the future. Thank you.
Thank you, Elias. I can't wait to see Patch solving the chicken and egg paradox. Everyone is like, well, demand, supply first. It's been around for a while, and I think you're on a mission to solve that problem, to develop high quality carbon removal markets. So good luck with that. It's not an easy one, but it's been fun to work with you, and I look forward to stay in touch.
Thank you.
All right, we are almost there. Thanks for hanging around. You'll get to meet all these amazing entrepreneurs. I just want to debrief quickly the quiz questions. So we had a first question around market size for carbontech. The correct answers was 1 trillion in the US and 6 trillion globally. Katie's going to drop a link with more info in the chat. The second question was about the scale at which we need to get to in terms of having a climate impact. And the correct answer here was at the billion ton of CO2 per year scale. Again, Kate is going to drop a link if you want to have more information on how different models estimated different numbers. Basically, that's the kind of scale you need to keep in mind. And the third question was around the value associated with carbon in the 45Q regulation in the US. And that was $35 per ton of CO2 utilized and $50 per ton of CO2 sequestered. And again, we have a little link that helps you to learn more about 45Q. All right, so we are going to move to the networking session. You can meet each other. There are basically three main ways you want to keep in mind. The first one is the Expo booth. You have a button on the left-hand side of your screen. Each startup has a booth. We also have a booth, so just come and join us. Just be mindful of others visiting the booth, and don't forget to share your contact information when you exit the room. The second way to engage is the networking button. So this is a randomized algorithm that's going to connect you one-on-one with someone in the audience for 5 minutes. And the third way is just to look and search via the People tab on your right upside screen. You can search for people, you can send private message, schedule meetings, or organize video calls. If this is too much information, we also have a tech guide at the main page of the event. And you can also just drop us a message in the chat and we'll help you. So that's a wrap. Thank you so much for joining again. Enjoy the networking. This is a really important part of the event. So enjoy and thanks for joining and goodbye.